my name is Malaika and I am a sophomore nursing student at Temple University. I'm so excited for GETT's new video series. My favorite GETT memory is definitely visiting each of the booths, meeting the amazing people who've been running them, and doing the little experiments to go along with them. Happy 20th anniversary, GETT!
Hi there, I'm representing the Delaware Valley Geo-Institute, and today we're going to build some mechanically stabilized Earth. The Geo-Institute is an organization serving geoprofessionals in the geo industry and is a part of the American Society of Civil Engineers.
Some of the sponsors of DVGI are shown on this slide. As you can see, our sponsors represent a variety of companies, including engineering consultants, material suppliers, contractors, and academic institutions. Many of us are civil or geotechnical engineers or geologists. Now let's meet some of our members.
Hi, I'm Salade and I'm from Lebanon. I came to the US to do my master's degree in civil engineering at Virginia Tech, and it opened an amazing opportunity for me. Now I'm working as a geotechnical designer at Kenneth Fleming, and I really like being involved both in design and fieldwork. For the past 3 months, I was a lead inspector on a turnpike project. We had to shut down travel lanes and do night shift work in order to inspect the quality of soil and rock. It was super exciting to work on operations behind the scenes of a massive project that impact our communities, and I can't wait for new adventures and new projects. Good luck to you and stay safe.
Hi, I'm Colleen Backlund. I'm a geotechnical engineer, and what my day today looks like is I help bring power from an energy source through the transmission line to where you're watching this video now. And how I help out with that is I design the foundations below ground that hold the structures up, that hold the wires up, that transport the energy. To get on this path, I had about 6 years of school. So I have my bachelor's and master's in civil engineering with a focus in geotech, and I've been loving serving the community for over 10 years now to help bring power to their homes.
My name is Dr. Kristen Sample-Lord, and I'm a professor of geotechnical engineering at Villanova University. I teach students about engineering with and on soil and rock, and I help them pursue careers in civil engineering. In addition to teaching, I also lead research teams studying how water and pollutants move through the ground, so we can design better infrastructure to protect our water sources and the environment. Studying civil and environmental engineering, and specifically geotechnical engineering, prepared me for careers in both industry and academia. And now I get to do what I love and learn something new every day.
Hi, my name's Teresa, and I'm the technical director here at Aero Aggregates. We use recycled glass bottles to make a lightweight and insulating aggregate, like you can see in the pile behind me. Some of my responsibilities include overseeing our quality control program, pursuing research and development opportunities, and educating engineers and architects all about foamed glass aggregates. I studied civil and geotechnical engineering at Drexel University, which prepared me well for this position and the others that I've had in construction and consulting.
Now that you've met some of us, and before we jump into our demo, we want to give you some very brief background on retaining walls. Retaining walls are structures that are built to hold in place a mass of earth or soil. They are used when we need a change in ground elevation over a comparatively short distance, usually in order to create more level and stable ground at the top or the bottom of the wall. Common retaining wall applications include roadway widening projects or ramps, bridge abutments and wing walls, and commercial or residential developments like you see in this photo. To introduce the type of retaining wall that is the focus of our demonstration, we want you to think about this question. What would happen if we built a retaining wall by just stacking blocks and filling with soil behind them? If you thought to yourself that the wall might be unstable and collapse, you are right. The self-weight of the blocks may not be enough to resist the pressure from the retained soil and water behind them. So why did the block wall on the previous slide collapse? The answer to this lies in the soil's strength. Soil is made up of individual particles. Some are very fine like clays and others are large like gravels. When we push soil together and compress it, the soil grains encounter a lot of resistance when they try to move past one another. However, if we attempt to pull apart a mass of soil, we will find that it takes much less force in order to do so. So coming back to our block wall, what types of materials could we use as reinforcement in our soil mass that will be strong in tension? If you answered plastic or steel, you are correct. A common geosynthetic that is used as MSE reinforcement are geogrids, and you can see some examples of these in the left photo. Geogrids are typically made from polyethylene, polypropylene, or polyester and have a design that allow the soil to interlock through the opening spaces in the grid. Steel reinforcement for MSE walls may be welded wire mesh or galvanized steel straps, like you see in the photo on the right.
So, as discussed, soil is strong in compression but weak in tension, and the geogrids that we use, or the reinforcements, are strong in tension but weak in compression. So I wanted to show you real quick what that means. So I have a cup of soil here, pushing on it. Very strong in compression. My hand's not going anywhere. It is not compressing at all, not squishing together. Meanwhile, it is super easy to pull apart. Very weak in tension, just crumbles. Meanwhile, the reinforcement that we use, I have a sample geogrid right here, I cannot pull it apart. But it is so easy to push together. Very weak in compression, very easy to squish. But pull it apart, you're trying, oh, it is so strong in tension. So what we do here with these MSE walls is we create a system that is both strong in compression and strong in tension by combining the soil and the reinforcement, the geogrid, together.
So let's go back to our block wall again. If we add geosynthetic or steel reinforcement between the layers of soil, the reinforcement provides tensile capacity within the soil mass and holds the soil in place. The friction and interlocking between the soil and reinforcements resists outward movement of the facing blocks and soil. The reinforcement and soil combined create mechanically stabilized earth, or MSE for short. We would be remiss if we didn't mention the importance of providing drainage behind any type of retaining wall. Because water can lower the strength of soil and apply quite a bit of pressure to the front face of the wall or to the reinforced soil, layers of high permeability stone and outlet pipes can be used to provide a pathway for the H2O to exit. With proper design, MSE walls can reach heights of over 100 feet tall and still be economic to construct. This photo is one of the largest MSE walls in North America. It holds up one of the runways at SeaTac Airport in Washington State.
Alright, so let's get started with our activity today. And we're going to construct our own mechanically stabilized earth. So they're going to construct or demonstrate the system going on behind the facing of the wall, where we have the soil and the reinforcement working together. So the materials that you will need: moist clay sand. Think about just the amount of water you need to build sand castles. So it's clumping together and holding together, but you don't have the water dripping out of it. So we have wood boxes that were very generously donated by Tensar for this activity. You could also use a cardboard box, like an Amazon box, and just duct tape it together, then use an X-Acto knife on the edges when we're done for it to come apart, come off, and then reinforcement. So for our activity today, we're just using construction paper. You could use like rugs, you could use actual geogrid. But the important thing is that as we are layering, so what we're going to do in this box, this will show the system with the soil and the reinforcement together, and the inner dimensions of it are 12 inches by 12 inches by 12 inches, so it's a cubic foot. And every inch of sand will have a layer of sand, then a layer of reinforcement, layer of sand, layer of reinforcement. So about every inch will have our construction paper. You need to make sure that it covers the entire layer. So for us, we're going to use a couple pieces of paper to make sure that we have that coverage. Otherwise, you would see some sloughing at the edges when we get to the end, when we load these. And then this cube over here will just be the play sand. sand cubes here. So this is the one that's reinforced. This is the one without the reinforcement. And we're going to stand on these to load these, take off the sides, and see what happens to our cubes. Okay, here we go. And it failed. Whereas my sand cake over here works.
We hope you enjoyed learning all about how MSC walls work and hearing about some of the careers that are possible in the geo industry. If you have any questions, please go on dvgi.org and contact any of the board members that are listed. Thanks for tuning in.
You can